Welcome to Ms. Parb's Flipped Classroom. Today we're looking at solving systems using tables and graphs, and the objective is to be able to solve a linear system using a table or a graph. A system of equations is two or more related unknowns or variables in a set of two or more equations. So if we had two variables, we need two equations. If we had three variables, we need three equations, and so on in order to be able to solve it. A linear system means it consists of linear equations, meaning that if you graph them, you will get straight lines, and all of your exponents on your variables will be 1 and no greater. The solution of a system is the set of values for the variables that make all of the equations true. So for an example, we're going to solve the system 3x plus 2y equals 8 and x plus 2y equals negative 8. If we just had one equation, we couldn't solve this, but since we have two unknowns and two equations, we can solve this. The first thing we want to do is take each one of these equations and solve it for y. So in the first one, we add 3x to both sides, then we divide by 2 to give us the equation y equals 3/2 x plus 4. We take our second equation, subtract x from both sides, divide by 2, and we get the equation y equals a negative 1/2 x minus 4. We're going to use our y equals button on the calculator, and for our y sub 1 we're going to put in our 3/2, put that in parentheses, x plus 4, and for the y sub 2, putting your fraction in parentheses, we're going to put a negative 1/2 x minus 4. And then we're going to go to the table button and we're going to view the table, and we're going to scroll down through the values until we find the x where y1 equals y2. And we see that that happens at x is negative 4, y1 and y2 are both negative 2. So the solution to this system is the ordered pair negative 4, negative 2. And to check this, we go back to our original equations and we plug in negative 4 for x and negative 2 for y, and check to make sure that it gives us the same answer. And we have to check both equations. We can't check just one of them. And you can see here we check both equations. They're both true. So this is indeed the solution to that system. So your guided is what is the solution for the system x minus 2y equals 4 and 3x plus y equals 5. And you want to solve those for y, graph them, find the point, just like we did in the problem before, and your answer will be the point 2, negative 1. Okay, if you think about the way you can take two lines and graph them, there's only three possible ways to graph the lines. They can cross, they can be on top of each other, or they can be parallel, in which case they will never cross. In this example, you have one solution. It's found where the lines cross. This is classified as consistent because it has a solution, and independent because it only has one solution. In this example, the lines are on top of each other. We really just have one line, so we have an infinite number of solutions. It's consistent because we do have a solution. It's dependent because we have an infinite number of solutions. And in this example, since the lines are parallel, they will never cross, so we do not have a solution, and this is classified as an inconsistent system because it has no solution. Okay, it's possible to classify systems without graphing, and the way you do that is to solve for y and compare the slopes and the y-intercepts. So we have the system 4y minus 2x equals 6. And 8y equals 4x minus 12. So we're going to take each one of those equations and solve them for y. So we add 2x to both sides, then we divide by 4. We get y equals 1/2 x plus 3/2. In this one, all we have to do is divide through by 8, and we get y equals 1/2 x minus 3/2. They have the same slopes. They both have a slope of 1/2. But they have different y-intercepts. This has a positive 3/2 as a y-intercept. This has a negative 3/2. Therefore, the lines are parallel and there is no solution, so this is an inconsistent system. So just to summarize these for you, if they have the same slope and the same y-intercept, then it's the same line, infinite and dependent. If they have different slopes, they'll cross, so there's one solution and it's independent. Same slope, different y-intercepts, you have parallel lines, no solution, and they're inconsistent. So for your Got It, here are 3 systems that they want you to classify as dependent, independent, or inconsistent without graphing. So solve these for y, compare the slopes and the y-intercepts. You will see that this system is inconsistent. This system is independent. And this last system is dependent.